Imagine this. You're standing at the edge of Scotland's most mysterious lake, 23 miles long and over 700 feet deep. The water is dark as midnight, so murky that even with modern sonar equipment, scientists can only see a few meters down. Now picture this. Something massive moves beneath the surface. Something that's been hiding in these depths for possibly thousands of years. Something that has turned skeptics into believers and believers into obsessed hunters. In 1934, a London doctor took a photograph that would become the most famous monster picture in history. For 90 years, that image has sparked debates, launched expeditions, and created a legend worth millions of dollars. But what if everything we think we know about the Loch Ness Monster is wrong? What if the truth is far stranger, far more complex, and far more unsettling than we ever imagined? Today, we're diving deep into the murky waters of Loch Ness to uncover the real story behind the world's most famous monster. And I promise you, by the end of this journey, you'll never look at this legend the same way again. To understand Nessie, we have to understand Loch Ness itself. This isn't just any lake. This is a 23-mile-long gash carved into the Scottish Highlands by glaciers over 10,000 years ago. It's deeper than the North Sea, containing more fresh water than all the lakes in England and Wales combined. The water is stained dark brown by peat, creating an underwater world as mysterious as outer space. But the real mystery begins long before modern monster hunters arrived with their cameras and sonar equipment. The story starts over 1,500 years ago, in the year 565 AD, when an Irish monk named Saint Columba encountered something terrifying in these very waters. According to ancient texts, Columba was traveling through the Scottish Highlands when he came upon the River Ness. Local Picts told him a disturbing story. A water beast had recently attacked and killed one of their people. As if summoned by their conversation, the creature emerged from the dark water and began moving toward Columba's companion, who was swimming across the river. The saint raised his hand and commanded the beast to retreat. According to the chronicle, the monster immediately turned and disappeared back into the depths. This wasn't just any religious tale. This was documented history recorded by Adamnan, abbot of Iona, who knew Columba personally. Think about that for a moment. 1,500 years ago, people were already telling stories about something dangerous living in these waters. Something large enough and aggressive enough to kill a human being. Something that would become the foundation of a legend that persists to this day. But here's where it gets interesting. The Picts, the ancient Celtic people who lived around Loch Ness, had been carving images of strange aquatic creatures into stone long before Saint Columba arrived. These weren't decorative symbols. These were warnings. These were records. These carvings show long-necked creatures emerging from water, creatures that look remarkably similar to modern descriptions of the Loch Ness Monster. Archaeological evidence suggests the Picts considered Loch Ness sacred, a thin place where the natural and supernatural worlds intersected. They built settlements around the loch, but rarely on its shores, as if they knew to keep their distance from whatever lived beneath the surface. For over 1,000 years after Columba's encounter, the monster remained largely in the realm of local folklore. Highland families passed down stories from generation to generation. Fishermen spoke in whispers of glimpses caught in early morning mist. Travelers reported strange wakes moving against the wind. But it was the coming of the modern road that changed everything. In 1933, the Scottish government completed a new road along the northern shore of Loch Ness. For the first time in history, travelers could drive the length of the loch with clear views of the water. What happened next would transform a local legend into a global phenomenon. On May 2nd, 1933, Aldi Mackay was driving along this new road with her husband when she spotted something extraordinary in the loch. She described seeing a huge animal rolling and plunging in the water, creating massive disturbances on the surface. When local newspapers reported her sighting, they used a word that would change everything: monster. The Inverness Courier ran the story with the headline, "Strange Spectacle on Loch Ness." Within weeks, the story had spread across Britain and then around the world. Suddenly, everyone wanted to see the Loch Ness monster. What followed was nothing short of monster mania. Reporters, photographers, and curiosity seekers descended on the small highland community. The locals, who had quietly lived with their legends for centuries, found themselves at the center of an international sensation. But the real explosion came 5 months later, on October 15th, 1933, when a London businessman named Hugh Gray took what he claimed was the first photograph of the monster. The image was blurry, showing what appeared to be a long-necked creature partially submerged in the water. Photographic experts examined the image and declared it genuine. The monster had evidence. The sightings continued throughout 1933 and into 1934. Each report seemed to confirm details from previous encounters. Witnesses described a creature 30 to 40 feet long, with a small head, long neck, and humped back. It moved with purpose, often submerging when approached. It seemed intelligent, almost shy. Then came the photograph that would define the legend forever. April 19th, 1934. Robert Kenneth Wilson, a respected London surgeon, was driving along Loch Ness when he allegedly spotted something moving in the water. He grabbed his camera and snapped 4 photographs. One of those images would become the most famous monster photograph in history. The picture showed what appeared to be a long neck emerging from the water, topped by a small head. The image was clear, well composed, and utterly compelling. Here was proof, captured by a medical professional with impeccable credentials. The Daily Mail published the photograph with Wilson's account. He described driving slowly along the loch when his companion spotted something in the water. Wilson stopped the car, grabbed his camera, and managed to capture 4 frames before the creature submerged. Of the 4 photographs, only one clearly showed the mysterious object. The image caused a sensation. Unlike previous blurry photographs and eyewitness accounts, this picture seemed to show the monster in perfect detail. The long neck, the small head, the way it emerged from the water, everything matched previous descriptions perfectly. For 60 years, the surgeon's photograph remained the crown jewel of Nessie evidence. It was analyzed by photographic experts, studied by zoologists, and reproduced in thousands of books, magazines, and documentaries. It convinced skeptics and gave believers solid ground to stand on. But like many legends, this one had a secret. In 1994, exactly 60 years after the photograph was taken, a man named Christian Sperling made a deathbed confession that shattered everything. Sperling revealed that the surgeon's photograph was an elaborate hoax, and he should know because he had helped create it. According to Sperling, the plot began with Marmaduke Wetherell, a big game hunter who had been commissioned by the Daily Mail to find evidence of the monster. When Wetherell's initial efforts failed, he was publicly ridiculed by the newspaper. Seeking revenge, he convinced his son-in-law, Christian Sperling, to help him create fake evidence. Sperling constructed a small model using a toy submarine fitted with a sculpted head and neck. The model was only about 18 inches long. They took it to Loch Ness in the early morning, photographed it in the water, then destroyed the evidence. But why was it called the surgeon's photograph? Because Wetherell knew his credibility was compromised. So he recruited Robert Wilson, a respected surgeon with no connection to the monster controversy, to present the photographs as his own discovery. For 60 years, the world's most famous monster photograph was actually an 18-inch toy submarine floating in shallow water. The revelation was devastating for true believers, but it also raised uncomfortable questions. If the most compelling evidence was fake, what did that say about all the other sightings and photographs? Had the entire legend been built on hoaxes and misidentification? The answer, as we're about to discover, is far more complicated than anyone imagined. Despite the revelation about the surgeon's photograph, the Loch Ness phenomenon was far from over. In fact, some of the most compelling evidence was yet to come, and it would come from sources that couldn't be easily dismissed. Tim Dinsdale was an aeronautical engineer, a man of science and precision. In 1960, he traveled to Loch Ness not as a believer, but as a skeptic, determined to debunk the monster legend once and for all. Instead, he became its most passionate advocate. On April 23, 1960, Dinsdale was scanning the loch with binoculars when he spotted something moving across the water. He quickly set up his 16mm camera and began filming. What he captured was 4 minutes of footage showing a dark object moving across the loch, creating a powerful wake. The film was revolutionary. Unlike still photographs that could be easily faked, motion picture film revealed details that couldn't be fabricated. The object in Dinsdale's film moved with purpose and power, creating a wake pattern that suggested something large moving beneath the surface. The Royal Air Force analyzed the footage using computer enhancement techniques developed for military reconnaissance. Their conclusion was startling. The object was animate, approximately 12 to 16 feet in width, and moving at roughly 10 miles per hour. It was definitely not a boat, log, or known animal. Dinsdale's film transformed him from skeptic to believer overnight. He spent the rest of his life at Loch Ness, accumulating over 50 sightings and helping establish the first serious scientific investigation of the phenomenon. But Dinsdale wasn't alone in his transformation from skeptic to believer. Throughout the 1960s and 70s, scientists, naturalists, and researchers began taking the Loch Ness phenomenon seriously. What they found challenged their understanding of what was possible. Dr. Robert Rines, a respected American inventor and lawyer, founded the Academy of Applied Science and turned its resources towards solving the Loch Ness mystery. Using sophisticated sonar equipment and underwater cameras, Rines and his team began the first systematic scientific study of the loch's depths. In 1972, Rines captured something extraordinary. His underwater camera, triggered by sonar contacts, photographed what appeared to be a large flipper moving through the water. The image showed a diamond-shaped appendage, roughly 4 feet long, unlike anything from a known aquatic animal. 2 years later, Rines's equipment captured even more compelling images. One photograph appeared to show the head and neck of a large creature, with visible features including what looked like horns or protrusions. Another image seemed to show a large body with visible texture and contours. These weren't blurry surface photographs that could be dismissed as floating logs or swimming birds. These were underwater images captured by scientific equipment, showing anatomical details of something large and unknown living in Loch Ness. The scientific establishment was forced to take notice. Sir Peter Scott, the renowned naturalist and founder of the World Wildlife Fund, examined Rhines's evidence and was convinced. He even proposed a scientific name for the creature, Nessiteris rhombopteryx, meaning Ness monster with diamond-shaped fin. But science moves slowly, and extraordinary claims require extraordinary evidence. While believers saw proof of an unknown species, skeptics demanded more data, better photographs, and reproducible results. The debate was just beginning. If something large and unknown was living in Loch Ness, science demanded answers. What could it be? How could it survive? And why hadn't we found definitive proof? The first question led to fascinating speculation. If the monster was real, what kind of animal could it be? The most popular theory suggested a surviving plesiosaur, a marine reptile that supposedly went extinct 65 million years ago. Plesiosaurs had long necks, small heads, and 4 flippers, matching many eyewitness descriptions perfectly. But there were problems with the plesiosaur theory. First, plesiosaurs were marine creatures that lived in saltwater oceans, not freshwater lakes. Second, Loch Ness was completely frozen during the last ice age, ending only 10,000 years ago. Any creature living there would have to have arrived after the ice melted. Stop. Some researchers proposed alternative explanations. Perhaps the monster was a surviving population of Basilosaurus, an ancient whale that went extinct millions of years ago. Or maybe it was an unknown species of long-necked seal adapted to freshwater life. The more exotic theories suggested even stranger possibilities. Could the monster be an amphibious creature that could leave the water? Some sightings described seeing the creature on land, moving with a humping motion like a massive caterpillar. But the most important question wasn't what the monster might be. It was whether Loch Ness could support a large unknown species at all. Marine biologist Adrian Shine spent decades studying the loch's ecosystem. His research revealed a disturbing truth. Loch Ness was essentially a biological desert. The dark, acidic water contained very little plant life, which meant very little food for fish, which meant very little food for anything larger. Shine calculated that Loch Ness could support perhaps 100 tons of fish at most. A single large predator weighing several tons would quickly exhaust that food supply. A breeding population of large animals would be completely impossible. Yet, the sightings continued, and they came from credible witnesses. Police officers, ministers, teachers, scientists, all describing encounters with something large and unexplained in the loch. Were they all mistaken? Were they all lying? Or was there something about Loch Ness that science didn't understand? The answer came from an unexpected source: advanced sonar technology. In 2003, the BBC sponsored the most comprehensive search of Loch Ness ever attempted. Using advanced sonar equipment, marine biologists systematically scanned every part of the loch, from surface to bottom. They were looking for any evidence of large, unknown animals. The results were definitive. The sonar detected nothing unusual. No large moving objects, no unknown species, no evidence of anything that could be described as a monster. The loch was exactly what marine biology predicted: a deep, cold, largely empty body of water with a limited ecosystem. But rather than ending the mystery, the sonar results deepened it. If there was nothing unusual in Loch Ness, what had thousands of witnesses been seeing for over 1,500 years? The human brain is a pattern recognition machine, evolved over millions of years to spot predators hiding in shadows and prey moving through tall grass. This remarkable ability kept our ancestors alive, but it also creates an interesting problem. our brains sometimes see patterns that aren't really there. Psychologists call this pareidolia, the tendency to perceive meaningful images in random stimuli. It's why we see faces in clouds and hear voices in static. It's also why a floating log, seen at distance through morning mist, can transform into a monster. But pareidolia alone couldn't explain the Loch Ness phenomenon. The sightings were too consistent, too detailed, and too persistent across different time periods and cultures. There had to be something more. Dr. Christopher French, a psychologist specializing in anomalous experiences, proposed a more complex explanation. According to French, the Loch Ness Monster wasn't just about misidentification. It was about expectation, suggestion, and the power of legend to shape perception. When people visit Loch Ness, they arrive with expectations. They've seen the photographs, read the stories, and absorbed decades of monster mythology. Their brains are primed to interpret ambiguous stimuli as evidence of something extraordinary. This priming effect is incredibly powerful. Studies have shown that people who believe in paranormal phenomena are more likely to report unusual experiences even when exposed to completely ordinary stimuli. Expectation literally changes what we see. But French's research revealed something even more interesting. The Loch Ness Monster wasn't just about individual psychology. It was about collective belief, social reinforcement, and the way legends grow and spread through communities. When someone reports a monster sighting, it doesn't happen in isolation. The report is shared, discussed, analyzed, and often embellished. Each retelling adds details, clarifies ambiguities, and strengthens the narrative. Over time, a brief glimpse of something unusual becomes a detailed encounter with a specific creature. This process is called social amplification, and it's incredibly common in paranormal reports. A culture that expects monsters will produce monster sightings. A community that celebrates monster reports will generate more monster reports. The psychology becomes even more complex when you consider the economic factors. Loch Ness generates millions of pounds in tourism revenue every year. Hotels, restaurants, tour operators, and gift shops all benefit from the monster legend. There are powerful incentives to keep the story alive, to interpret ambiguous evidence as supportive, and to promote the mystery rather than solve it. But psychology and economics still couldn't explain everything. Some sightings came from people with no interest in monsters, no knowledge of the legend, and no incentive to fabricate stories. Children playing by the water's edge, fishermen focused on their work, skeptical scientists conducting research. What were they seeing? Loch Ness is a strange place, and not just because of its legendary inhabitant. The loch sits on the Great Glen Fault, a massive geological fracture that runs across the Scottish Highlands. This creates unusual conditions that can produce genuinely mysterious phenomena. Seismic activity along the fault can create standing waves called seiches, where water suddenly rises at one end of the loch and falls at the other. These waves can appear without warning, creating disturbances on the surface that look like something large moving beneath the water. The loch's unusual shape also creates optical illusions. At 23 miles long and only 1 mile wide, Loch Ness acts like a giant telescope, magnifying objects at great distances and distorting perspective. A small bird floating far away can appear much larger and closer than it actually is. Weather patterns add another layer of mystery. The Scottish Highlands are notorious for sudden mist, temperature inversions, and atmospheric distortions. These conditions can make ordinary objects appear to float, change shape, or move in impossible ways. But the most significant natural factor might be the loch's unique biology. While marine biologist Adrian Shine was correct that Loch Ness couldn't support large predators, he also discovered something unexpected in the loch's depths. Floating near the bottom, Shine found large mats of organic debris, vegetation, and detritus that had accumulated over thousands of years. Sometimes these mats break free and rise to the surface, propelled by decomposition gases. When they emerge, they create dark shapes that move across the water surface before sinking back down. These rising debris mats could explain some monster sightings, but not all of them. Many witnesses described active, purposeful movement that couldn't be explained by floating vegetation. Then there were the waves. Loch Ness occasionally produces mysterious waves that travel against the wind, appearing to be caused by something moving beneath the surface. These waves are real, measurable phenomena that have been documented by multiple independent observers. Some researchers suggest these waves are caused by underwater currents, temperature differences, or seismic activity. Others propose more exotic explanations involving unknown species of large fish or undiscovered geological phenomena. Where there's a famous mystery, there will always be people willing to create fake evidence for money, fame, or simple mischief. The Loch Ness Monster has attracted more than its fair share of hoaxers, and their activities have both complicated the mystery and revealed important truths about human nature. We already know about the surgeon's photograph, but that was just the beginning. In the decades that followed, Loch Ness became a playground for increasingly elaborate hoaxes. In 1975, a group of British students created a fake monster using a foam body, wooden frame, and outboard motor. They successfully fooled several tourists and made local newspapers before revealing their prank. The 1970s also saw the rise of sophisticated underwater hoaxes. Divers would position fake monster parts on the loch bottom, then guide researchers to discover them with underwater cameras. One particularly elaborate scheme involved creating a fake monster corpse using fiberglass and latex. But the plan fell apart when the hoaxers couldn't agree on how to present their evidence. The most successful monster hoax wasn't visual at all. It was audio. In 1978, researchers recorded mysterious sounds in Loch Ness using underwater microphones. The sounds seemed to be vocalizations from large animals, unlike anything produced by known fish or marine mammals. For years, these recordings were cited as compelling evidence for unknown creatures in the loch. Only later was it revealed that the sounds were produced by small boats with modified engines, designed to create mysterious underwater noises. But perhaps the most revealing hoax came in the 1980s, when a team of researchers claimed to have captured definitive sonar evidence of the monster. Their equipment allegedly detected a large, moving object in the loch's depths, and they presented detailed sonar traces as proof. Independent analysis eventually revealed that the sonar signatures were artificially created, probably by dragging objects through the water on cables. But what made this hoax significant wasn't the fake evidence itself. It was how eagerly. Yet the hoaxes also revealed something else. Even when researchers proved that specific pieces of evidence were fake, it didn't end the sightings. People continued to report encounters with something unknown in Loch Ness. The hoaxes might have muddied the waters, but they didn't explain away the entire phenomenon. This led to a disturbing possibility. What if some of the dismissed evidence wasn't actually fake? What if genuine anomalies had been lumped together with elaborate hoaxes and dismissed en masse? Behind every famous mystery are real people who claim to have experienced something extraordinary. At Loch Ness, These witnesses come from every walk of life, every level of education, and every degree of skepticism. Their stories form the heart of the monster legend, and they deserve to be heard. Margaret Monroe was 8 years old in 1934 when she saw something that changed her life forever. She was playing by the shore of Loch Ness with her sister when they spotted a large animal moving through the water near the bank. The creature had a long neck, small head, and moved with slow, deliberate grace. Margaret watched the animal for several minutes before it submerged and disappeared. She ran home to tell her parents, but they dismissed her story as childhood imagination. Margaret never forgot what she saw, and 70 years later, she still described the encounter in vivid detail. What makes Margaret's story compelling isn't just her consistency over decades. It's that her sighting occurred before the monster became internationally famous, before the media circus, before the tourist industry. She saw something before she knew she was supposed to see something. Similar accounts come from dozens of other witnesses whose sightings predate the modern monster legend. Highland families who lived around the loch for generations often had their own monster stories, passed down through oral tradition, long before the first newspaper reports. But the most compelling witnesses might be those who had everything to lose by reporting their experiences. In 1960, Reverend W.L. Dobbs was driving along Loch Ness when he saw what he described as a large animal crossing the road in front of his car. The creature was massive, moving with a humping gait, and disappeared into the undergrowth before Dobbs could stop his vehicle. As a minister in a small Highland community, Dobbs knew that reporting a monster sighting would subject him to ridicule and skepticism. He kept quiet about his experience for months before finally sharing it with trusted friends. Even then, he asked them not to publicize his account. Police Constable John MacLeod faced a similar dilemma in 1965 when he encountered something extraordinary while patrolling the shores of Loch Ness. MacLeod described seeing a large, dark animal emerge from the water and move onto the beach. The creature was about 20 feet long, with a long neck and 4 flippers. MacLeod watched the animal for several minutes before it returned to the water and submerged. As a police officer, he was trained to be an accurate observer, but he also knew that reporting a monster sighting could damage his professional credibility. He filed an official report, but asked his superiors to keep it confidential. These reluctant witnesses pose a challenge for skeptics. If the monster sightings were all based on misidentification, hoaxes, or psychological suggestion, why would respectable people risk their reputations by reporting impossible encounters? The answer might lie in the nature of anomalous experiences themselves. Dr. Kenneth Ring, a psychologist who studied people who reported unusual encounters, discovered that these experiences often share common characteristics. They tend to be brief, unexpected, and emotionally powerful. Witnesses often describe feeling changed by what they saw, even when they can't fully explain it. Ring also found that people who report anomalous experiences aren't more gullible or fantasy-prone than the general population. If anything, they tend to be more observant, more detail-oriented, and more troubled by their inability to explain what they witnessed. This suggests that the Loch Ness witnesses aren't simply making up stories or misidentifying ordinary phenomena. They're reporting genuine experiences that don't fit into conventional categories of explanation. But what exactly are they experiencing? By the 1970s, the search for the Loch Ness Monster had evolved into something resembling a scientific discipline. Cryptozoology, the study of hidden animals, attracted researchers from around the world who believed that unknown species might still exist in remote locations. These weren't amateur monster hunters or publicity seekers. These were serious researchers with advanced degrees, sophisticated equipment, and scientific methodology. They brought a new level of rigor to the investigation of anomalous phenomena. Dr. Roy Mackal was a biochemist at the University of Chicago who became fascinated by reports of unknown animals. In the 1970s, he led several expeditions to Loch Ness using advanced sonar equipment, underwater cameras, and systematic observation methods. Mackal's team accumulated hundreds of hours of sonar data showing unusual underwater contacts. Most were easily explained as fish, floating debris, or equipment malfunctions. But a small percentage showed large, moving objects that didn't match any known phenomena. One sonar contact, recorded in 1975, showed an object approximately 20 feet long, moving at considerable depth through the loch. The object maintained consistent speed and direction for several minutes before disappearing into deeper water. The sonar signature suggested something with the density and movement patterns of a large animal. Similar anomalous sonar contacts were recorded by other research teams over the following decades. The data was frustrating because it suggested something unusual was present in the loch, but never provided clear enough images or consistent enough results to prove anything definitively. The cryptozoologists also collected an enormous database of eyewitness accounts, analyzing them for patterns and consistency. What they found was remarkable. Despite coming from different time periods and independent sources, the witness descriptions showed striking similarities. Witnesses consistently described a creature 30 to 40 feet long, with a small head, long neck, and humped back. The animal appeared to be dark-colored, moved with purpose, and seemed to avoid human contact. Most sightings occurred in calm weather during early morning or late evening hours. These consistencies were either evidence of a real animal or evidence of a remarkably persistent cultural archetype. The cryptozoologists believed they had found patterns that couldn't be explained by coincidence or cultural transmission. But their research also revealed disturbing gaps in the evidence. Despite decades of investigation using increasingly sophisticated technology, no research team had managed to capture definitive proof of an unknown species in Loch Ness. The absence of physical evidence became a growing problem. No bones, no tissue samples, no clear photographs, no unambiguous sonar signatures. For a creature that supposedly lived in a confined space and had been spotted thousands of times, the Loch Ness monster was remarkably good at avoiding detection. Some cryptozoologists proposed that the creature was highly intelligent and deliberately avoided human contact. Others suggested that multiple species might be involved, or that the animals spent most of their time in underwater caves that hadn't been discovered. But as the years passed and the evidence remained elusive, even dedicated believers began to question their assumptions. The arrival of advanced technology in the 1980s and 1990s promised to finally solve the Loch Ness mystery. Satellite imagery, computer-enhanced photography, advanced sonar systems, and remotely operated vehicles would surely find definitive evidence if anything unusual was living in the loch. The technology revolution began with Operation Deep Scan in 1987, the most comprehensive sonar survey ever attempted at Loch Ness. 24 boats equipped with sophisticated sonar equipment swept the entire loch in a coordinated search pattern. The results were mixed. Deep Scan detected several large, unidentified objects in the loch's depths, but none could be definitively identified as unknown animals. Most anomalous contacts turned out to be underwater rock formations, sunken logs, or schools of fish. However, 3 sonar contacts remained unexplained. These objects appeared to be large, moving, and biological in nature. They generated considerable excitement among researchers, but follow-up investigations failed to relocate or identify them. The 1990s brought even more sophisticated technology. Underwater cameras with motion sensors were deployed throughout the loch. Hydrophones recorded underwater sounds. Computer programs analyzed thousands of photographs for evidence of anomalies. One of the most ambitious projects was led by Discovery Communications in 2001. They used a remotely operated vehicle equipped with high-resolution cameras to explore every part of Loch Ness, including deep underwater caves that had never been systematically examined. The ROV investigation found fascinating geological formations, including underwater waterfalls and previously unknown caves. But it found no evidence of large, unknown animals. The deep caves, which some researchers had hoped might serve as monster lairs, turned out to be too small and too barren to support large creatures. In 2003, the BBC sponsored the most thorough scientific examination of Loch Ness ever attempted. Using advanced sonar technology, marine biologists created a complete 3-dimensional map of the loch's underwater topography, while simultaneously scanning for any evidence of large animals. The BBC investigation was definitive. They found no evidence of unknown species, no unexplained sonar contacts, and no underwater formations that could serve as habitats for large creatures. The loch was exactly what conventional science predicted: a deep, cold, relatively sterile body of water with limited biodiversity. But even as technology failed to find monsters, it revealed other mysteries. Satellite imagery showed unusual wave patterns on Loch Ness that couldn't be explained by wind or boat traffic. Computer analysis of thousands of photographs revealed statistical anomalies in the distribution of unexplained objects in monster photographs. Hydrophone recordings detected mysterious sounds that didn't match any known acoustic phenomena. The technology wasn't finding monsters, but it was finding genuine mysteries that conventional science couldn't easily explain. This led to a fascinating possibility. What if the Loch Ness phenomenon wasn't about unknown animals at all? What if it was about unknown physics? In 2009, Dr. Luigi Garlascelli, an Italian chemist specializing in the scientific investigation of paranormal claims, proposed a radical new theory about the Loch Ness monster. According to Garlascelli, the phenomenon might be related to quantum mechanical effects that were only beginning to be understood. Garlascelli's theory was based on recent discoveries in quantum physics showing that large objects can sometimes exhibit quantum properties under specific conditions. He suggested that the unique geological and electromagnetic properties of Loch Ness might create conditions where quantum effects become visible at macroscopic scales. The theory was highly speculative, but it addressed some puzzling aspects of the monster phenomenon. It could explain why sightings were unpredictable and why physical evidence was so elusive. If the monster was essentially a quantum phenomenon, it might exist in a superposition of states, becoming real only when observed. The quantum theory also explained why advanced technology had failed to find definitive evidence. Quantum systems are notoriously sensitive to observation, often changing their behavior when measured. Traditional investigation methods might actually prevent the phenomenon from manifesting. While most scientists dismissed Garlascelli's theory as pseudoscience, it raised interesting questions about the relationship between consciousness, observation, and physical reality. Could the act of looking for the monster actually influence what people see? Parallel research in psychology was revealing that human perception is far more subjective and malleable than previously understood. The brain doesn't simply record sensory input like a camera. It actively constructs reality based on expectations, memories, and cultural conditioning. This led to what some researchers called the consciousness hypothesis for anomalous phenomena. According to this theory, monsters, ghosts, and other paranormal experiences might represent interactions between human consciousness and unknown aspects of physical reality. The consciousness hypothesis was controversial and largely unprovable, but it offered a way to reconcile the persistent reports of anomalous experiences with the lack of physical evidence. It suggested that the monster might be real in some sense, without being a biological creature swimming in Loch Ness. But not everyone was ready to abandon the biological explanation entirely. While cryptozoologists searched for unknown animals and physicists speculated about quantum phenomena, environmental scientists were uncovering a different kind of mystery in Loch Ness. What they found challenged everything we thought we knew about the loch's ecosystem and opened up entirely new possibilities for explaining the monster phenomenon. Dr. Adrian Shine, the marine biologist who had declared Loch Ness too sterile to support large predators, made a startling discovery in the early 2000s. Using advanced underwater cameras, his team found evidence of a previously unknown ecosystem thriving in the loch's deepest parts. At depths of over 200 meters, where sunlight never penetrates and temperatures hovered just above freezing, Shine discovered colonies of bacteria and microorganisms that were completely unknown to science. These organisms weren't dependent on photosynthesis like surface plants. Instead, they derived energy from chemical processes, similar to life forms found around deep ocean volcanic vents. This discovery revolutionized our understanding of Loch Ness. The loch wasn't a biological desert after all. It was home to a unique ecosystem that had been invisible to previous research because it existed in complete darkness at crushing depths. But the mystery deepened when Shine's team discovered something even more extraordinary. The bacterial colonies showed signs of organization and behavior that seemed almost intelligent. They formed complex geometric patterns on the loch floor, created structured formations that resembled cities or settlements, and responded to disturbances in coordinated ways. Could these microbial communities be connected to the monster phenomenon? Some researchers suggested that large bacterial mats might occasionally rise to the surface, creating dark shapes that could be mistaken for animals. Others proposed that the bacterial colonies might produce bioluminescence or other visual effects that could create the illusion of large creatures. But the most intriguing possibility came from marine biologist Dr. Peter Rask-Moller, who studied electric fish in the Amazon. Moller suggested that if unknown species of electric fish existed in Loch Ness, they might explain some of the most puzzling aspects of monster sightings. Electric fish can generate powerful electromagnetic fields that interfere with electronic equipment, potentially explaining why cameras often malfunction during monster encounters. They can also coordinate their electrical discharges, creating collective effects that might produce unusual sonar signatures or underwater sounds. The electromagnetic theory gained support when researchers discovered that Loch Ness sits on one of the most geologically active areas in Scotland. The Great Glen Fault generates continuous low-level seismic activity, creating piezoelectric effects in the surrounding rock that produce natural electromagnetic fields. These electromagnetic fields might attract or influence unknown species of electric animals. They might also directly affect human brain function, potentially creating the neurological conditions that some researchers believe are responsible for paranormal experiences. The environmental detective story was revealing that Loch Ness was far stranger and more complex than anyone had imagined. It wasn't just a deep, cold lake. It was an electromagnetic anomaly sitting on top of an unknown ecosystem surrounded by geological forces that science was only beginning to understand. While scientists debated quantum theories and electromagnetic anomalies, the Loch Ness Monster was transforming from a mysterious legend into a multi-million-pound industry. By the 1990s, Nessie had become Scotland's most famous export after whiskey, generating enormous economic benefits for the Highland region. The transformation began innocently enough. Local businesses started selling monster-themed souvenirs to visitors who came hoping to catch a glimpse of the famous creature. Hotels offered monster watching packages. Tour boats provided narrated cruises of the loch with guides who knew all the best monster stories. But as the tourism industry grew, something troubling began to happen. The commercial incentives started influencing the evidence. Tour operators had strong reasons to encourage monster sightings. Hotel owners benefited when mysterious encounters kept visitors coming back. Gift shop proprietors needed fresh monster stories to sell postcards and t-shirts. This created what sociologists call a feedback loop of belief. The more successful the monster tourism became, the more pressure there was to produce monster encounters. Tour guides began pointing out monster wakes that were obviously caused by boats. Hotel staff started sharing recent sightings that were carefully timed to coincide with tourist seasons. The commercialization reached a peak in the 1990s when several entrepreneurs attempted to create artificial monster sightings for tourist entertainment. Remote-controlled submarines designed to look like monsters were tested in the loch. Mechanical creatures operated by hidden divers made scheduled appearances for tour groups. Most of these commercial monsters were obvious fakes, but they created a new problem. They made it even harder to distinguish between genuine anomalous experiences and manufactured entertainment. The situation became more complex when DNA technology arrived at Loch Ness in the 2000s. Environmental DNA sampling, which can detect genetic material from any organism that has lived in a body of water, promised to finally settle the monster question scientifically. In 2018, Professor Neil Gemmell from the University of Otago led an international team of scientists in the most comprehensive eDNA study of Loch Ness ever attempted. They collected water samples from throughout the loch and analyzed them for genetic material from any large unknown species. The results were definitive. There was no DNA evidence for any large unknown animals in Loch Ness. No plesiosaurs, no giant fish, no undiscovered species of any kind. The genetic analysis confirmed what sonar surveys had suggested. Loch Ness contained exactly what mainstream biology predicted, but Gemmell's study also revealed something unexpected. The loch contained unusually high levels of eel DNA, suggesting a population of European eels much larger than previously estimated. Some of these eels, Gemmell suggested, might grow to considerable size in the loch's deep, cold waters. Could large eels explain some monster sightings? Eels can grow over 6 feet long and swim with undulating motions that might create the impression of humps moving through water. They're dark-colored, elusive, and capable of living in the deep, cold conditions of Loch Ness. The eel theory provided a biological explanation that satisfied many scientists, but it didn't account for sightings that described creatures with long necks, small heads, and flipper-like appendages. Eels simply don't match those anatomical details. The DNA study closed one chapter in the Loch Ness story, but it opened another. If there were no unknown animals in the loch, what had thousands of people been seeing for over 1,500 years? As the scientific evidence against biological monsters accumulated, researchers began examining the Loch Ness phenomenon from a different perspective. Instead of asking what people were seeing in the loch, they started asking why people needed to see monsters at all. Anthropologist Dr. Sophia Kingshill spent years studying monster legends around the world. Her research revealed that lake monsters aren't unique to Scotland. Similar legends exist in virtually every culture that lives near large bodies of water. Lake monsters have been reported in Russia, Canada, the United States, Scandinavia, and dozens of other countries. What Kingshill found fascinating was how these legends changed over time to reflect contemporary fears and anxieties. Medieval lake monsters were described as dragons or demons, reflecting religious worldviews. Victorian lake monsters became mysterious prehistoric survivors, reflecting growing awareness of geological time and extinction. Modern lake monsters are often described in quasi-scientific terms, reflecting our technological age. The Loch Ness monster, Kingshill argued, served as a cultural mirror that reflected changing attitudes about science, nature, and the unknown. When people looked at the dark waters of Loch Ness, they saw whatever their culture most feared or desired. In the 1930s, during the Great Depression, people needed something mysterious and wonderful to believe in. The monster provided hope that there were still unknown realms to explore, still mysteries that hadn't been solved by science and technology. In the 1960s and 70s, during an era of environmental awareness, the monster became a symbol of nature's resilience and the importance of protecting wild places. Believers argued that Loch Ness must be preserved as habitat for an unknown species. In the 1990s and 2000s, as global communication networks spread information instantly around the world, the monster became a focus for communities of believers who used the internet to share evidence and reinforce each other's experiences. The cultural mirror theory explained many puzzling aspects of the monster phenomenon. It explained why sightings increased during times of social stress. It explained why monster descriptions evolved to match contemporary expectations. It explained why the phenomenon persisted, even as scientific evidence against it accumulated. But the cultural mirror theory also raised uncomfortable questions about the nature of evidence and belief. If people were seeing what they expected to see, what did that say about all the other things we think we know about the world? Psychologist Dr. Christopher French conducted experiments showing that people's expectations dramatically influenced their interpretation of ambiguous stimuli. When shown identical images of objects floating in water, people who had been primed with monster stories were significantly more likely to describe seeing animate creatures, while people primed with natural explanations described seeing logs, birds, or waves. French's research suggested that the monster phenomenon might reveal more about human psychology than about unknown animals. Our brains are constantly interpreting incomplete information, filling in gaps with assumptions based on our experiences and expectations. This raised a profound question. If human perception was so subjective and malleable, what did that mean for eyewitness testimony in general? What did it mean for scientific observation? What did it mean for our understanding of reality itself? The arrival of the internet in the 1990s transformed the Loch Ness monster phenomenon in ways no one could have predicted. Suddenly, monster researchers around the world could share information instantly, collaborate on investigations, and build communities of believers that transcended geographical boundaries. But the internet also democratized monster evidence in troubling ways. Anyone with a digital camera and basic photo editing software could create convincing monster photographs. Video editing technology made it possible to produce realistic monster footage that could fool casual observers. The result was an explosion of alleged monster evidence that was increasingly difficult to verify or debunk. Every blurry photograph, every ambiguous video clip, every alleged sonar reading found its way onto websites, forums, and social media platforms where it could be shared, analyzed, and amplified by thousands of users. One of the most significant internet age developments was the emergence of real-time monster hunting. Webcams positioned around Loch Ness allowed people around the world to watch the loch continuously, looking for signs of unusual activity. When something interesting appeared on camera, alert systems notified registered users who could tune in immediately. The webcam system generated hundreds of alleged monster sightings, most of which turned out to be boats, birds, floating debris, or technical glitches. But the few unexplained incidents created tremendous excitement and brought new attention to the monster legend. Social media platforms like Facebook and YouTube created new ways for people to share monster experiences and build communities around their beliefs. Monster hunting groups formed online, organizing expeditions, sharing equipment, and developing increasingly sophisticated investigation techniques. But the internet also enabled more sophisticated debunking efforts. Skeptical researchers could quickly analyze alleged monster evidence, cross-reference witness accounts, and expose hoaxes or misidentifications. Digital forensics made it possible to detect photo manipulation and video fakery with unprecedented accuracy. The result was a kind of arms race between believers and skeptics, with each side developing more sophisticated methods for supporting their positions. Believers used advanced sonar equipment, underwater cameras, and computer analysis to search for evidence. Skeptics used the same technologies to demonstrate that alleged evidence had natural explanations. One of the most influential internet developments was the emergence of crowdsourced monster research. Projects like the Loch Ness exploration website allowed users to submit sightings, photographs, and analysis from around the world. The data was compiled into searchable databases that revealed patterns and trends in monster reports. What these databases showed was both fascinating and troubling. Monster sightings clearly increased during tourist seasons, peaked on weekends, and correlated with media attention. This suggested that social and psychological factors were playing a major role in generating reports. But the databases also revealed genuinely puzzling patterns. Certain locations around the loch produced significantly more sightings than others, even when accounting for tourist traffic. Certain weather conditions were associated with increased reports of unusual phenomena. These patterns suggested that while many sightings were influenced by expectations and suggestion, some might be related to real environmental factors. The internet age had made the Loch Ness Monster phenomenon more complex, more global, and more contentious than ever before. It had also made one thing perfectly clear. After more than 90 years of intensive investigation, the mystery was far from solved. As scientific evidence against the monster accumulated and skeptical analysis became more sophisticated, true believers found themselves fighting a defensive battle. But rather than abandoning their beliefs, many doubled down, developing increasingly elaborate theories to explain why definitive evidence remained elusive. Some believers argued that the monster was far more intelligent than previously assumed. According to this theory, the creature had learned to avoid human contact, hiding in underwater caves during the day and emerging only under specific conditions when detection was unlikely. The intelligence theory was supported by behavioral observations that seemed to show purposeful evasion. Monster sightings often ended when boats approached or cameras were pointed in the creature's direction. The animal seemed to know when it was being watched and deliberately sought to avoid documentation. Other believers proposed that multiple species were involved. Instead of a single breeding population of large animals, Loch Ness might host several different types of unknown creatures. This would explain the variation in witness descriptions and the apparent ability of the animals to avoid comprehensive detection. The multiple species theory gained support from sightings that described creatures with different characteristics. Some witnesses reported long-necked animals with small heads, while others described more whale-like creatures with prominent humps. The variation might indicate diverse species rather than inconsistent observations. Perhaps the most exotic believer theory involved interdimensional or paranormal phenomena. According to this hypothesis, the monster wasn't a biological creature at all, but some kind of manifestation that existed partially in our physical reality and partially in unknown dimensions or planes of existence. The interdimensional theory explained why the monster was so difficult to detect with conventional scientific methods. It existed in a state of quantum superposition, becoming physically real only when observed under specific conditions. This would account for the elusiveness of physical evidence while maintaining the reality of witness experiences. Believers also pointed to the limitations of scientific investigation methods. Sonar surveys, they argued, could miss creatures that spent most of their time in underwater caves or buried in bottom sediment. DNA sampling might fail to detect animals that had sophisticated methods of avoiding genetic contamination of their environment. The believer community developed increasingly sophisticated counter-arguments to each piece of skeptical evidence. When sonar surveys found nothing unusual, believers suggested that the creatures were hiding in unexplored cave systems. When DNA analysis detected no unknown species, believers proposed that the animals had methods of containing their genetic material. But perhaps the strongest believer argument was the persistence and consistency of the witness reports themselves. Over 1,500 years, thousands of independent observers had described encounters with something large and unknown in Loch Ness. The consistency of these reports across different time periods, cultures, and levels of education suggested that something real was being observed, even if science couldn't explain what it was. Dr. Henry Bauer, a retired Virginia Tech professor who studied scientific anomalies, argued that the Loch Ness phenomenon represented a failure of scientific methodology rather than evidence against unknown animals. According to Bauer, science was so committed to existing paradigms that it couldn't properly investigate phenomena that challenged fundamental assumptions. Bauer's critique resonated with believers who felt that the scientific establishment had prejudged the monster question and was unwilling to consider evidence that contradicted conventional biology. They saw themselves as keeping an open mind in the face of scientific dogmatism. The believer's last stand revealed something important about the relationship between evidence, belief, and human psychology. When people have profound experiences that don't fit conventional categories, they don't simply abandon their beliefs when presented with contradictory evidence. They adapt their beliefs to accommodate new information while preserving the core conviction that their experiences were real and meaningful. While believers developed increasingly elaborate theories to explain the lack of physical evidence, skeptical researchers were systematically dismantling the monster legend piece by piece. By the early 2000s, they had accumulated a devastating case against the existence of unknown animals in Loch Ness. The skeptical argument began with basic biology. Marine biologist Dr. Adrian Shine had demonstrated that Loch Ness simply couldn't support a breeding population of large predators. The loch's ecosystem was too limited, too sterile, and too constrained to sustain even a single large unknown animal, let alone the breeding population that would be necessary for species survival. Skeptics also pointed to the complete absence of physical evidence despite decades of intensive searching. No bones, no tissue samples, no clear photographs, no unambiguous sonar contacts. For animals that supposedly lived in a confined space and had been observed thousands of times, their ability to avoid leaving any trace of their existence was remarkably convenient. The pattern of sightings also supported skeptical interpretation. Monster reports increased during tourist seasons, peaked on weekends, and correlated with media attention. This suggested that social and psychological factors were driving the phenomenon rather than encounters with real animals. Skeptical researchers had also identified natural phenomena that could explain most monster sightings. Floating logs, swimming deer, diving birds, standing waves, optical illusions, and acoustic effects could account for the vast majority of reported encounters. But the skeptics' most powerful weapon was photographic analysis. Using computer enhancement techniques, they had systematically examined every famous monster photograph and found natural explanations for all of them. The surgeon's photograph was a hoax. The Dinsdale film showed a boat. The underwater photographs captured by Robert Rines showed sediment clouds and lake bottom features. Skeptical analysis had revealed that the monster phenomenon was essentially a cascade of misidentifications, hoaxes, and psychological effects, amplified by media attention and commercial interests. There was no mystery left to solve because there had never been a real mystery in the first place. Dr. Joe Nickell, a prominent skeptical investigator, summarized the case against the monster in brutal terms. According to Nickell, the Loch Ness Monster was one of the most thoroughly debunked phenomena in the history of anomalous claims. The evidence against its existence was overwhelming, comprehensive, and definitive. Nickell argued that continued belief in the monster represented a failure of critical thinking and scientific literacy. People who still believed in Nessie after seeing the evidence were either ignorant of the facts or psychologically incapable of accepting reality. The skeptical triumph seemed complete when the comprehensive DNA analysis of 2018 found no evidence of any large unknown species in Loch Ness. Professor Neil Gemmel's study had used the most advanced genetic detection methods available, and the results were unambiguous. There were no monsters in the loch. But even as skeptics celebrated their victory, something unexpected was happening. Monster sightings weren't decreasing. If anything, they were becoming more frequent and more detailed. The debunking efforts seemed to have no impact on people's experiences at Loch Ness. This created a puzzle for skeptical researchers. If they had definitively proven that no monsters existed in the loch, why were people still reporting encounters with them? What was the disconnect between scientific evidence and human experience? The answer, as we're about to discover, would challenge both believers and skeptics to reconsider everything they thought they knew about the mystery. In 2019, something extraordinary happened that changed our understanding of the Loch Ness phenomenon forever. It wasn't a monster sighting or a new piece of evidence. It was a revelation about the nature of human perception that had implications far beyond the shores of Loch Ness. Dr. Suzanne O'Connell, a neuroscientist studying visual perception, was analyzing brain scans of people who had reported paranormal experiences. What she discovered revolutionized our understanding of how the human brain processes unexpected or anomalous information. O'Connell found that when people encounter something their brain can't easily categorize, the visual cortex enters a state of hyperactivity that can actually create visual hallucinations. These aren't psychological delusions or conscious fabrications. They're neurological responses to cognitive overload, where the brain literally generates visual information to fill gaps in understanding. The implications were staggering. People who reported monster sightings weren't lying, weren't psychologically disturbed, and weren't simply misidentifying natural phenomena. They were experiencing genuine neurological events, triggered by encounters with ambiguous stimuli that their brains couldn't properly process. O'Connell's research explained many puzzling aspects of the monster phenomenon. It explained why witness reports were so consistent across different time periods and cultures. The human brain has universal patterns of response to cognitive uncertainty, creating similar hallucinations in similar situations. It explained why monster sightings were often brief and elusive. The neurological events that created the visual experiences were temporary, lasting only as long as the brain remained in a state of processing overload. Most importantly, it explained why physical evidence was so elusive. The monsters that witnesses saw were real visual experiences generated by their own brains, but they weren't physical creatures that could leave traces in the environment. But O'Connell's research raised as many questions as it answered. If the monster experiences were neurologically generated, what was triggering them? What was it about Loch Ness that consistently produced the cognitive uncertainty that led to visual hallucinations? The answer came from an unexpected collaboration between neuroscientists and geologists. Research revealed that Loch Ness sits on top of one of the most geologically active areas in Scotland, generating continuous low-level electromagnetic activity that can affect human brain function. The electromagnetic fields produced by geological activity in the Great Glen Fault were weak but persistent. They weren't strong enough to cause obvious symptoms, but they were sufficient to subtly influence neural activity in people with certain genetic predispositions. This electromagnetic influence explained why only some people reported monster experiences, while others saw nothing unusual. Individual differences in electromagnetic sensitivity determined who would experience the neurological effects that generated visual hallucinations. The revelation provided a scientific explanation that satisfied both believers and skeptics. Believers were vindicated because their experiences were real neurological events, not delusions or fabrications. Skeptics were satisfied because no unknown animals were required to explain the phenomenon. But the revelation also opened up entirely new questions about the relationship between environment, neurology, and perception. If electromagnetic fields could trigger visual hallucinations, what did that mean for other reported paranormal phenomena? How many ghost sightings, UFO encounters, and monster reports might be explained by environmental influences on brain function? The Loch Ness Monster had led us to a discovery about human consciousness that was far more extraordinary than any prehistoric creature could have been. Today, more than 90 years after Aldi Mackay's first modern sighting, the Loch Ness Monster remains as mysterious as ever, but for completely different reasons than anyone expected. The monster has evolved from a cryptozoological puzzle into a window into the deepest mysteries of human consciousness and perception. Modern researchers at Loch Ness aren't looking for unknown animals anymore. They're studying the electromagnetic properties of the Great Glen Fault, mapping the neurological effects of geological activity and exploring the boundaries between objective reality and subjective experience. The Loch Ness Center has transformed from a monster museum into a research facility investigating anomalous perception phenomena. Scientists from around the world come to study the unique conditions that make Loch Ness a natural laboratory for understanding how environment influences consciousness. But the monster legend itself continues to thrive. Tourist boats still cruise the loch, searching for signs of Nessie. Gift shops still sell monster memorabilia. Witnesses still report encounters with something unexplained in the dark waters. The persistence of the legend reveals something profound about human nature. We need mysteries. We need the possibility that there are still unknown realms to explore, still questions that science hasn't answered, still wonders that defy explanation. The Loch Ness Monster serves that need perfectly. Whether it exists as a biological creature, a neurological phenomenon, or a cultural archetype, it represents our refusal to accept that the world has been completely mapped, cataloged, and explained. Recent developments have added new layers to the mystery. Climate change is affecting the temperature and chemistry of Loch Ness, potentially altering the electromagnetic properties that influence human perception. Pollution and tourism are changing the loch's ecosystem in ways that might affect the environmental triggers for anomalous experiences. Some researchers worry that we might be losing the conditions that made Loch Ness special. If the electromagnetic effects diminish, or if the loch's unique properties are altered by environmental change, future generations might lose access to the neurological phenomena that created the monster legend. Others argue that the mystery will adapt and evolve, finding new forms of expression as our understanding of consciousness and perception advances. The monster might become a symbol for quantum consciousness, dimensional physics, or discoveries about reality that we haven't even imagined yet. What's certain is that the Loch Ness Monster has taught us something unexpected about ourselves. We're not passive observers of reality. We're active participants in creating our own experience of the world. Our brains, our expectations, and our environment interact in complex ways that can generate phenomena that are simultaneously real and inexplicable. As our journey through the depths of the Loch Ness mystery comes to an end, we're left with more questions than answers. But perhaps that's exactly as it should be. The Loch Ness Monster has survived every attempt to explain it away, because it serves a function that goes beyond biology, psychology, or even neuroscience. It represents our need to believe that mystery still exists in the world, that there are still frontiers to explore and discoveries to be made. In an age when satellites can map every square meter of the Earth's surface and DNA analysis can identify the genetic signature of any living thing, the Loch Ness Monster reminds us that the biggest mysteries might not be hiding in the depths of Scottish lochs. They might be hiding in the depths of human consciousness itself. The story of Nessie is really the story of us. It's about how we perceive reality, how we process the unknown, and how we create meaning from mystery. It's about the delicate balance between skepticism and wonder, between evidence and belief, between what we know and what we hope might still be possible. Every time someone stands on the shores of Loch Ness and gazes into those dark waters, they're participating in a tradition that stretches back over 1,500 years. They're asking the same questions that St. Columba asked in 565 AD. What lies beneath? What mysteries remain unsolved? What wonders are still waiting to be discovered? The waters of Loch Ness will keep their secrets, as they always have, but they'll also keep inspiring us to look deeper, to question more, and to remain open to possibilities that our current understanding can't explain. The monster may not be what we thought it was, but the mystery it represents is more profound than any prehistoric creature could ever be. In searching for Nessie, we've discovered something far more extraordinary: the unlimited capacity of human consciousness to create meaning, wonder, and hope in a universe full of unanswered questions. So the next time you hear someone dismiss the Loch Ness Monster as just a myth or just a hoax, remember what we've learned. The monster is real, just not in the way anyone expected. It lives in the intersection between mind and environment, between perception and reality, between the known and the unknown. And as long as humans need mystery in their lives, as long as we need to believe that there are still wonders waiting to be discovered, the Loch Ness Monster will continue to surface in the dark waters of our imagination, reminding us that the greatest mysteries of all might be the ones we carry within ourselves. The search continues. The mystery endures. And somewhere in the depths of Loch Ness, whether real or imagined, ancient or modern, the monster waits for the next curious soul brave enough to peer into the darkness and wonder what might be looking back. What do you think? Have we finally unmasked the Loch Ness Monster? Or have we simply discovered that some mysteries are meant to remain mysterious? The answer, like the monster itself, might be lurking just beneath the surface, waiting for you to decide what you're willing to believe. Until next time, keep questioning, keep wondering, and never stop looking for the magic that might still be hiding in the world around us. Because sometimes, the most important discoveries aren't the ones that solve mysteries, but the ones that help us understand why mysteries matter in the first place.